Hello to everyone, my name is Slava, I am aerospace engineer, and this is a second part of my video about building, assembling and flying my first FPV drone called BumbleBee. In the first video, I have been telling you about components I used, how I built a drone, difficulties I faced, and I have shown you some baseline sanity check flight test, which was mostly hovering. This video will be about more extensive flight test campaign. I will tell you about how did I learn to fly FPV on more skilled and complex level, which test I did on my BumbleBee, and finally, what modifications I did on my drone after gaining some flight experience. So fasten your seatbelts, we are taking off. And for those of you who are interested what happened with my leg, well, this is not because of the drones. So let's continue our flight. Flight story begins not by flying a BumbleBee, but firstly getting some elementary experience of flying FPV and getting experience on a little bit different drone. In order to avoid emergency situation happening, because a BumbleBee is not yet proven and me is also not yet having enough FPV flight skills, I decided to go for first flights with a DJI Neo 2. This is a drone which with the goggles and FPV controller supports manual mode, so I decided to make a couple of flights with this drone and then go to BumbleBee. So on what I did on Neo 2 is first getting generally familiarized with flying with FPV goggles, getting used to controls when you're don't see a control yourself, and or in other words, just getting used to FPV flight. So I've been flying in a normal mode, just to flying in sport mode, trying to do some nice cinematic shootages, as you can see now, and finally, after some time, I decided to make a little bit step forward and go to fly Acro mode, or it's called a manual. And what generally I can say is that flying a manual mode, even on underpowered Neo 2, is really nice experience. Drone feels really so much more free compared to angle mode, and so much unrestrained. So I've been trying to do some flips, trying to do some risky rapid turns. However, the story with Neo 2 had a little bit of a dark side. So shortly speaking, what's been happening is that on the first flight, when I just believed that I have enough skills, I decided to make a little bit risky thing and fly through the football gates. And because the DJI Neo 2 camera is wide angle and I haven't yet get enough experience, I overestimated the distance between a drone and this football gate horizontal bar and just hit it and crashed it. But fortunately for me, everything was fine with the drone, and its repair didn't costed me like arm and leg. However, it was a valuable lesson to learn for future, to get a bit more experience, and if I decide to fly through some gates or obstacles, first to try to do it on a lower speed in order to avoid excessive repair or any repair cost in the future. So now, when I have just enough experience in FPV and have experience of flying with the goggles, it's time to fly BumbleBee. So here you can see takeoff from a BumbleBee. The first outdoor flight I decided to do in angle mode. On a first flight, I've been doing some general control checks, like I have been exercised some baseline hovering, resisting a wind in a hovering. I have a little bit tried to see what is the maximum speed of the drone. Actually, it's not much for Cinewhoop. Maximum what I reached is around 100 kilometers per hour. However, this first angle flights helped me to get some initial confidence in a BumbleBee. And the next flight was not an angle mode, but an Acro flight. So here you can see I take off in a park. I'm doing some just baseline loops, and actually in angle mode, and you can see what I do in 3, 2, 1, I switch to Acro mode. As you can just see, the drone is making a rapid pitch down, then pitch up, and only then, just before ground, it recovers. And you might want to ask me what happens, and I will tell you, because of flying in an angle mode, I get a bit used to pushing and holding a pitch stick in its maximum position, and I haven't accounted, what actually happened is that I get used to not to notice this, and I switch it to Acro mode in a moment when actually this pitch stick was put to a maximum. I will remind you that in an Acro mode, the pitch stick controlling the pitch rate. So effectively, drone just did what it was now supposed to do. It did a rapid 600 degree per second pitch down maneuver. Then I needed to react, and maybe there was some kind of overshoot from my side. But fortunately for me, this accident, this was just a near miss, but not a crash, which make me very happy. However, after this case, I had a couple of my hairs like a silver. But it was also a valuable lesson to learn for futures that you must never switch from angle to Acro mode with any non-zero stick inputs. Otherwise, you will have a story what I had. But anyway, let's continue. Fortunately, at this stage, the extreme near misses and crashes compilation finished, and I started to learn more about BumbleBee in the Acro mode. I have been trying to exercise some first flips, like left, right, backward and forward. Also for my own pilot training, I have been considering orbiting. For example, here you can see that I'm orbiting around some kind of island on the middle of a lake. This is to learn or get a practice with some coordinated stick movements. So for example, in orbiting is a combination of pitch and yaw stick inputs. Other than that, I've been practicing the 8-shape orbiting around this football gates, which you know related to previous drone crash. But fortunately, this time I had much more experience, and any of these 8-shape orbits didn't end that bad for me. Instead, all was fine. What else I did? I tried, when I had much more confidence, I tried a higher speed fly through the gates. Here we can see it. What I especially like it is doing drops. So what I call a drop is that you take off, you make maybe some panoramic turn, and then you just dive down. Like when your drone is equipped with 4K camera, is especially nice to see these footages in this resolution after a flight. And last but not least, I've been practicing how it's so-called power loop. So with a power loop, unlike a flip, is when a drone not doing just rotation around its axis, but doing a loop like aerobatic aircrafts have. Fortunately for me, I had a good enough altitude reserve because what I just revealed when that I exited this power loop from altitude much somewhat lower than I entered this loop. But anyway, I've been practicing these exercises I told you, like orbiting, flies through gates, H-shape orbiting, drops, and flips for maybe around 1 hour of total flight time. And actually, after this around 1 or 2 hours of flight time, I have accumulated enough flight confidence, skills, and experience to be capable to do more complex things. And actually, on this stage, our story about original pilot training and BumbleBee just trivial flying just finishes, and it's time to talk about the next step. The next step, or the next chapter of this video, is actually about a drone testing, or in other words, answering a question like what objectively drone can do and what is not, and about validating or confirming my original estimates. So for testing, I decided to consider the following things. Firstly, I would like to check for how durable a drone is, or how good a battery can hold its charge, or how many times drone can fly. And this includes both a hovering or just a regular open-air flight. The next question, how far drone can fly. And third, is not really about its how far or how long. I would like to look for my drone vibrations to understand whether it needs any filter tuning and so on. So now let's have a look. So our first test is being the battery indoor endurance test. And actually, it's quite straightforward. So what I'm actually been doing, I remove all of these tables, shelves, and so on from my flat where I fly, and I'm just hovering in my room for as much as needed to drop battery voltage from 4.2 volts per cell to 3.5 volts per cell, where 3.5 is actually a safe lower limit for lithium polymer batteries. Theoretically, it is possible to go even to 3.2 volts per cell. However, it's quite often a little bit risky in terms of long-term battery health, because the difference between 3.5 volts per cell, 3.2 and 3, and then some damage to a battery is passed very quickly. You can find it if you look on a typical lithium polymer battery discharge curve. So, as you probably remember from my previous video, I worked for my 1480 mAh battery. I've been predicted 10 minutes of hovering, and actually, the results was better than my estimate. In reality, my battery was shown to have a more capacity than this 1480 mAh. And actually, despite that this 1880 mAh was accumulated almost exactly as my analysis was telling, within 10.5 minutes, the drone have continued to hover around maybe 2 minutes more, and resulted with the overall capacity in a hovering like 600 mAh, and correspondingly the overall hovering time is 12 minutes. But this is actually just a usual hovering test. Interesting Another aspect to look on battery is to see what actually happens in a usual regular flight. So here you can see I'm just doing some not a rush fly around the park, and you can see that the current draw is a bit more than in a hovering. In a hovering it's around 7 or 8 amps, but here you can see somewhere around 12, 13. And actually what I found that in not very quick flying, the drone can fly for around 6-7 minutes, which is actually just fine. Of course, it's not as much as some top-level DJI drones, or however, for just handmade FPV drones, is actually of this side, it's actually just okay. In my future projects, I will be doing a bigger drones and I will show you playing with bigger propellers, and actually it will lead to a bigger flight times, but for 3.5-inch drone is just fine. The next step I am going to do is actually check for kind of a maximum range. You might want to ask me, okay, but Slava, it was actually done before, and what you're going to do? So actually for a range test, maybe, yeah, you're right. I decided not to go for big risk and maybe just go and fly it for up to my kind of comfort zone, because I was a little bit scared to fly without testing fail-safe up to the limit of its capabilities. So here we can see I take off in a windless weather and hold the vision line of sight with a drone, and by that method I succeed to fly around 1 kilometer with a 60 megabyte per second bitrate, and only after 1 kilometer I started to have this first drops of bitrate. Of course, if you allow a bigger drops of bitrate, drone can fly maybe much farther, but maybe on the stage I decided to make little pause, but we'll keep you updated later on. And the last part of the test campaign, or I would maybe call it not a test but inspection, it is an inspection of a drone vibrational and filter settings and characteristics. What is required to ensure that gyroscope of a drone is not fed with any resonance frequencies and behaves normal? What critically affects controllability of a drone? For making an inspection, I have configured a black box to record me the unfiltered raw gyroscope data for roll, pitch, and yaw, and then in a black box I will now compare unfiltered and filtered gyro data for all 3 axes. So first you can see here is the unfiltered roll. You can see that before any filters the maximum noise, or we have these peaks at around 358 Hz. However, after application of filters, this array of peaks actually disappears, meaning that the default filter settings are actually okay. The similar situation happens for pitch, where we have again a maximum noise at 358 Hz, but after application of filters, it disappears. Finally, situation for yaw is a little bit different in terms of frequency. It happens at 412 Hz, but nevertheless, filters are also eliminating these peaks, leaving for all 3 axes the noise at only 100 Hz, which I might guess is because of, let's say, some, how to call it, maybe not a rigid attachment of some of components like antennas, but nevertheless main danger like this high intensity resonances of a frame are eliminated. And at this moment of time I consider it just as okay. And now When we are done with frequency analysis, it is time to start drawing conclusions about BumbleBee and making overall feedback. And now it is a time for a post-flight feedback. After a pilot training campaign and a drone test campaign, I have accumulated several experiences in piloting and testing a drone, and it's now time to share my overall feedback as well as to tell about what changes I did to a drone after all this experience. So let's start. As you could probably see in my previous video, where I was telling about building of a drone, I originally made a buzzer of a drone to fit on an action camera mount, while USB-C was put in a sophisticated hole. However, on the basis of my experience, I found several problems with this mounting solution. Firstly, because I put a buzzer on my action camera mount, I can't use this. I cannot mount my action camera properly. And actually, I would like to have this option in the future. So what firstly I did is I twisted my flight controller for wiring run be shorter, and I moved my buzzer just between my control antennas. Second, originally, in order to access a flight logs USB-C cable, this frame is supplied with a special USB-C extension. And for originally, it was supposed to be mounted or fitted in through the tiny hole. However, as my day-to-day experience with drone went, I found that over a time, this little USB-C extension just slowly drags inside the drone. And in one of the day, I simply discovered that I can no longer normally connect drone to my computer, and I need to disassemble it, which is quite, to be honest, I don't like this process because actually the specifics of this frame, especially its disassembly and assembly, is that you need to be very first accurate with the wiring and then clamp and screw it. So what I decided to do, I have a little bit updated or resoldered harness on this USB-C extension, and instead of putting in this small hole, I simply put a zip tie, connected it to my GPS module. The next change of a drone I did was a disabling of magnetometer. Magnetometer is originally a device which is intended to give me a proper heading or and direction of your home location. However, despite several attempts of recalibration, I didn't succeed to make my magnetometer works fine, which gave me a wrong direction of a home. And finally, I have decided to disable this sensor. And after this, by relying purely on a GPS, I started seeing adequate direction to home on my OSD. What I'm personally quite happy, because what actually it allows me to do is that if I, for example, want to fly in some new space, in some new terrain, and I lose a visual orientation where I am located, at least with a properly directed GPS heading or GPS home heading, I can find my way home. And last but not least is the problem with altitude indication. Same as in the magnetometer option, I found that there is an option to disable barometer, but to be honest, I don't really like this option because unlike heading, altitude is quite critical parameter, and I would like to still have two sources of its indication. I have been attempted to cover my altitude meter or barometer with a foam to prevent this blinking of altitude indication, but unfortunately, some flight tests didn't show any significant improvement. Regarding tuning of a parameter of a sensor, regarding tuning of my filters and PIDs, on this step, because of relatively small amount of overall flight time and quite satisfying performance of my filters, I decided not to do any changes at all, because as you could see in just before, my filters are doing job relatively quite well, and throughout my experience, I didn't notice that any problem with the controls. Perhaps for a CineWhoop frame, there is not much necessity to go digging into these PIDs, but at least I'm happy that my default filters settings are removing this major resonance. So on this stage, I leave this aspect of drone setting as unchanged. And regarding my overall experience of flying this drone, I really loved it. I really like how powerful compared to Neo 2 this drone is, how many more freedom in an Acro mode is, and I would say every flight it feels like, despite that it can go up to 6 minutes, just sometimes you just go into the flow and feel that time pass really quickly. And of course, I'm going to continue flying this drone and telling you, my subscribers, about more and more experiments and the test. Particularly, my next videos will be potentially about checking new beta flight version. This is 4.6, or it's also called 2512, where I am quite interested in some GPS and altitude hold modes. And perhaps later on, I will check the iNow firmware on this drone. Thank you very much for watching this video. Please put a like and subscribe on my channel, and leave comments. I'm always happy, and your questions, I'm always happy to answer it, help. Also, I'm happy for you to propose some new topic, for example, maybe some learning material. Have a good day. Bye.